Every year, London Fire Brigade attend to more than 100,000 incidents to help and save lives. However, nearly 50% of those turned out to be false alarms. Only 20% are actual fires. So imagine the firefighters are distracted by the false alarm when there is a real emergency somewhere else. They wouldn't be able to make it in time, and it could cause serious consequences. So, how should we handle this? Hello, everyone. My name is Alexis, and in the last 6 weeks, I worked with London Fire Brigade, analyzing call data and leveraging machine learning techniques to predict false alarms. This is a record of fire and false alarm in London in 2016. 2 days are quite distinct with highest numbers, November the 5th and June the 23rd. Does anybody know why? Well, yes. November the 5th is the bonfire night. It is usually a busy day for firefighters, as expected. On the other hand, on June the 23rd, when UK voted to leave the European Union, the number of false alarms reached its record high in the last 3 years. Most of the calls were from Westminster, where the number was actually doubled on that single day. But is this entirely unexpected? Is there a pattern behind this? So these are the questions we're trying to answer at London Fire Brigade. The goal of this project is not to simply build a model and replace the human operator, but rather by using machine learning and AI techniques to develop better profiles for false alarms, so that the control room officers can ask more strategic questions and mobilize resources more quickly and logically, maybe sending 1 fire engine instead of 4. So to achieve this, I started by analyzing the most obvious. For example, by visualizing the time of the call and the property, we can already observe that while hospitals and offices are more likely to have false alarms in the morning when people started working, hotels and restaurants are more prone to false alarms at midnight. Then I extend this generic profile to include the duration of the call, borrow, and phone lines, and feed this information into a machine learning model. In all predicted false alarms, the model was able to achieve 80% accuracy, which is not bad. But it also means that the rest of 20% are actually fires, misclassified as false alarms. And for high-risk incidents such as this misclassification could put people's life in danger. So my question was, can I do better? So to improve the model, I decided to explore the data in a different angle by looking at the individual profiles. We've already known that some boroughs have more false alarms than others, but if we take a look at the postcode, it is clear that the most vulnerable locations are actually hospitals, following a different pattern. Similarly, we could do the same to identify the most frequent telephone numbers, which are often belong to the monitoring companies. And then, by feeding this new information into the model, I was able to bring the misclassified false alarms from 20% to 10%. With the improvement of the model, what we would really like to know is what factors are more important for that prediction, for which I have used the Shapley value. Shapley value is originally from game theory, and it is now commonly used for model explainability. The higher the Shapley value is, the more a feature contributes to the prediction, that is false alarms in our case. So these are the top 13 important features to our model. And as can be seen here, that call rate, which is the frequency of the call, is the most influential. And interestingly, offices and investments are also positive indicators for false alarms. So in conclusion, in this project, I used machine learning and feature importance to develop a better profile for false alarms. the code package has been sent to London Fire Brigade, which will help them cooperate with policymakers and monitoring companies to tackle this issue. It is also very useful for the control room officers to respond to the emergency calls in a more effective and efficient way. And most importantly, this demonstrates that the power of AI is incredible and will change the society in some very deep ways. Thank you very much.